Hello, everyone. Mr. Sutherland here, and today what we're going to do is wrap up our little unit on probability with a interesting topic on something called expected value. I know the video last time was longer than I like them to be. This one should be back in the normal time range. Um, and I just want to apologize for that. There was just a lot going on in that last section today. Should be a little more straightforward because it takes one more step over what we were doing with probability. So I think for expected value, um, it's best to kind of just talk about an example, and then I'll talk about the math behind it. So here's the example that I want to go through. Let's say we have a group at school who is trying to raise money. And so they're going to do it by doing a raffle. So they sell 500 raffle tickets, and those tickets cost $2 each. And the prizes that they're going to give are going to be this. So there's going to be one prize. The first place winner is going to get $100. The second prize, which there are going to be just one. So one prize, second place is going to get $50. And then there are going to be five third place winners. So we'll say five prizes for the third place winners. And those third place winners are going to get $20 each. And so my question would be, what's the expected value in this problem? And what that means is, if I'm to play this raffle, I'm to spend my $2, what is my expected outcome? Am I expected to win money? Am I expected to lose money? How much am I expected to win or lose? And so when I do these, I like to use a table to do these. So what I'll do is I'll make a table where I have my outcomes. I have the value of that outcome. And then I have the probability that that outcome will occur. So, for instance, the first outcome is I win first place. Now, if I win first place, I'm just going to make this a little smaller to take up less space. If I win first place, I paid $2, I win $100. So my value is I actually made $98. And the probability that that happens is 1 out of 500. Now, the probability that I am second place. Well, the probability that I'm in second place is also 1 out of 500. My value of that, I win 50, so I really made $48. Then there's third place. There were 5 of those, so I have 5 out of 500 chance there. They won 20, they spent 2, so the value is 18. And then the last one are my people who did not lose, who got no prizes. They lost their $2. And so you have a probability of 493 out of 500. So if I want to figure out my expected value, sometimes it's called the expected outcome in this, what I'm going to do is just take my value times my probability of that happening. And I account for each case. So for each one, I just multiply those two. So I really have -2 times 493 over 500. I put all of that into the calculator and I get -1.5. So what that means is every time I buy a lottery ticket, I'm expected to lose $1.50. So the result here is I lose $1.50 per ticket. And this is just in the long run. That's what would you average losing. And so if you're designing a raffle like this, you want to design it so that the person buying is losing money. If everybody makes money on your raffle, then your raffle isn't going to make money. And so that's how these things are designed. So if I want to find the expected value of an event, then what I'm going to do is really just take the value of the first event times the probability that that happens plus the value of the second event times the probability that happens plus all the way down. And I just add those up and that will give you the expected value. So let's take a look at an example here. So number one, Calvin Butterball's father offers to pay him $90 if he makes all A's or pay him $10 for each A he earns. However, he must decide in advance which offer to accept. Calvin is a good student and estimates his probability of earning A's to be 0.9 in algebra, 0.7 in English, 0.8 in chemistry, 0.6 in Spanish. Which option should he choose? So let's go through and figure out his expected value for each option. So the first one is that if he gets all A's. So first, I need to get the probability that he gets all A's. Well, that's just the probability of getting an A in algebra is 0.9 times the probability of getting an A in English is 0.7 times the probability in chemistry is 0.8 times the probability in Spanish is 0.6. So if I take those and multiply those, I end up with the probability that he gets all A's is 0.3024. And so the expected value for this one is he makes $90 if he gets all A's. So I have 90 times 0.3024. So if I do that times 90, his expected value is 27.216. So based on the probabilities, if he were to choose this option, he would expect to make a little over $27 based on his probability. Now, his other option was $10 for each A. So what I'm going to do is, again, I'm going to make my table. So I have outcome, I have value, and I have my probabilities. So the outcome of an A in algebra, the probability of that is 0.9. He makes $10. An A in English, values $10. The probability is 0.7. An A in chemistry, values $10. The probability is 0.8. And then in Spanish, values $10. And then he has a probability of 0.6. So my expected value here is 10 times 0.9 plus 10 times 0.7 plus 10 times 0.8 plus 10 times 0.6. So we have 9 plus 7 plus 8 plus 6. So with this method, we have $40, I believe. $30. So this one is $30 is his expected value. So which one should he do? He should take the second deal based on the probabilities because the mathematical expectation for that deal is higher. Taking logic and thinking out of it, you're just using the probabilities. You're following the numbers. Okay, let's look at number 2. You draw one card from a standard deck of playing cards. If you pick a heart, you win $10. If you pick a face card, which is not a heart, you will win $8. If you pick any other card, you lose $6. What's the expected value if you play this game? So let's set up our table. So we have the outcome, we have the value, and we have the probability. Now this one, they've set it up so you lose $6. So basically it costs $6 to play. If you win, you would get 16. So you're really winning 10. So let's say the first outcome is you pick a heart. And according to this, if you pick a heart, you win $10. Now the probability of that happening is there are 13 out of 52 cards that are hearts. The second way that you can win is you pick a face card, which is not a heart. Because if you pick a face card that's a heart, it goes in this first category. So face cards that's not hearts, there are 9 of those. There are 9 out of 52. And if you do that, you win $8. Any other card, you're going to lose $6. So here I have 13 plus 9 is 22. That means I have 30 cards possible where I would lose. And so now my expected value here is 10 times 13 over 52 plus 8 times 9 over 52 minus, because it's negative 6 times 30 over 52. And so I'm going to calculate that here real quick to see what my expected value would be for playing this game. So I have 6, the last one, 6 times 30 over 52. And I get the expected value to be positive. So 0.423. If the expected value is positive, you should play that. Even if you lose at the beginning, if I imagine playing this game 100 times, I will end up with $42. It's just following the mathematics. So that is a game that you definitely want to play. Number 3. This is another raffle one. So based on what we did with the first example, why don't you go ahead and pause the video, try this problem, and come back and see how you did. All right, here, let's see what we have. A raffle offers 1 first prize for 1,000, 2 second prizes of 300, 20 third place prizes of $10 each. If 8,000 tickets were sold at 75 cents each, find the expected winnings for a person buying the ticket. So let's start my table. So I have my outcome. I have the value of that outcome, and I have the probability that that outcome will occur. So there's 1 first prize. So let's do that. There's 1 first place. There's 1 out of 8,000 tickets that wins. Now, if I win $1,000. I paid 75 cents. So I'm really winning $999.25. If I get second prize, there are 2 of those. So I have 2 out of 8,000. For that, you win 300, so it's really $299.25. And then we have third place. If you get third place in this one, there were 20 of those, so 20 out of 8,000. Each of those wins $10. So really, they have $909.25 is what they are making. And then everyone else, all others, you've paid the 75 cents and you've lost. So you're negative 0.75, and there are 23 people that win, which means there's 9,977 people out of 8,000 that are tickets that lose. And so now, the expected value of playing this game. So I have my first value times my first probability plus my second value times the probability. And so I didn't always do these with tables, but I have found making that table really helps to keep me and my thoughts organized as I do these problems. And so now I'm going to go ahead, this will take a second. I'm going to go ahead and calculate my expected value by plugging this into the calculator. And hopefully I plug everything in correctly. If you get a different answer, it's possible I just do a quick typo. I'm just trying to get this done quickly for you guys here. Let's see, we have 20 out of 8,000 for third place. And then the last one is we are losing 75 cents, and there are 7,977 of those out of 8,000. I put all that in, and I get this, that they are losing, a person loses on average a little bit more than 52 cents a ticket. So that's expected value. If you're designing it and this is your your game you're running to raise money for charity, this is what you'd want to run because in the end, you're going to make money. Yeah, they're going to lose in the long run. Whereas this one, example two, you'd want to change the game because you're the one now losing the money. The player has the advantage. And so expected value can be used in all sorts of different areas. Um, how many hits do you expect a batter to get over a season? What's their expected value based on average and when the hits occur? That's used in analytics for basketball and baseball quite a bit. So it's a cool little branch, just one little extension of probability. I hope this is helpful. There'll be a couple on the review worksheet for you to try, and I think you should be doing well with it. All right, take care, guys. Talk to you later.